Alright, it is time for another module, and this one is kind of interesting because it is what allows your script to execute CLI or command line interface commands. Section 2 kind of talks about the necessity of why this is a good thing to do, because there are a lot of things, certain things you can do with Node modules. In fact, a lot of things you can do with Node modules. But it is also very convenient to be able to execute just about any commands that you want to run using from inside your script. Because there are utility programs that are difficult to replicate using an npm module, and obviously the downside of using a CLI command is now your script is kind of dependent on the operating system that you're using. Most of the time, it's not too big of a deal because a lot of systems, a lot of websites are hosted on Linux systems. So as long as you stay with the usual commands on the Linux system, you'll be fine. On the other hand, if you're using some exotic, command line programs, then you might have a problem of your script not being very portable, so it cannot go across different platforms easily. So after that, we're going to talk about the child process module, which is built in, so there's no need to install anything. The fact that this is actually old, so let me refresh it. You do have to use a require in order to bring in the module. I just changed it in my notes and then I forgot to update refresh the web page over here. So it's important to understand what a process is. A process is a technical term. It refers to a program in execution. So this sentence here is really quite important because you probably will encounter the term process from time to time, even when you're just writing a web script and not really taking a class in operating system. So it's kind of important to understand what a process is. It is a program in execution. A program is nothing more than the specification of how something is done on the computer. It's kind of like a cookbook, right? You cannot eat a cookbook. A cookbook is not delicious. It doesn't have doesn't have any flavor. Because it's really just a book. It contains only the instructions to make food items that may be delicious, that may smell really good. So a process, on the other hand, is an instance of the instructions being followed. So when a cook or when a chef or when a person is following a cookbook to actually cook some food, that is process. Okay, it's not so much the person. Okay, the person is more like the processor, but the person following the cookbook to cook some food is the process. So it's a little bit abstract because it's not referring to a concrete thing. It is referring to an action. The action is the processor following the instructions of a program. So that is a process. So as you can imagine, when your script is running, it is a process. So that is why when you use PM2 to stop, one of your apps, it's really managing your process. PM2 stands for Process Management version 2. So as you can see, PM2 is, what you can use to manage your processes. When a program in execution, such as your script, is trying to start another program, which is a CLI program in this case, it has two choices. The first one is for the first program to give itself up in order to have the new program to reuse the same process. On the other hand, you can also have the process to run the new program, start a new process to run the program, and then to continue the existing process. Or they both can be occurring at the same time. Let me use the chef analogy again. The first approach, this approach here to use the same process is basically saying, okay, I'm not going to finish the instructions of this cookbook. I'm going to switch to another cookbook. And in that case, once you switch to a different cookbook, there's no way to go back to the original cookbook and follow the original cookbook anymore. So in this specific case, you have one single process where you give up the program that it was following in the first place in order to start another program, but using exactly the same process. On the other hand, when we are talking about this analogy here, it's a little bit hard because a person is really not a is not a process. A person is more like a processor. But I don't want to talk about how the computer, how the operating system perform multiprocessing. So in this analogy, we'll use a person to pretend that that is actually a process. So in this case, you're basically having a main chef in the kitchen cooking some particular item, but he or she needs help, okay, to do some other to cook other dishes as well. So what is happening here is the main chef is going to bring in another person into the kitchen, so the other person can follow another cookbook potentially to cook up some other dishes. The two can happen at the same time, but they can also they can be in sequence. So the main chef can go like, okay, I'm following these instructions of this particular cookbook, but right now this one calls for a particular item that needs to be prepared. Until this item is prepared, I can't really do anything. So the other person, so the original main chef, can now take a break, rest, and have the other person who was just brought into the kitchen to perform whatever instruction is in the cookbook to prepare the other item. When that person is done, then the main chef can continue, because there's a dependency between what the assistant chef is trying to accomplish and what the main chef is trying to accomplish. So we are going to use the latter approach, which means we are going to look into how to start a new process to perform an operation. And the main process, for the most part, is waiting. Okay, so we are going to talk about that in just a little bit here. Section 4 talks about synchronous versus asynchronous. This is nothing new. We talked about this quite a bit already. Depending on the CLI command and what it is supposed to do, it may take the command some time to complete. So it all depends on what type of command you are trying to get the system to execute. Some commands, that can basically, you can look for a specific file within a large file system. That can take a long time to accomplish. Other tasks, such as let's just list everything in a particular folder, that typically doesn't take a whole lot of time. Or you want to check out the current time, there are commands to do that too, and that doesn't take up a lot of time either. So as a result, the synchronous method is usually preferred when a Express script executes a CLI command, because asynchronous, not synchronous. Asynchronous method is better because while a particular request coming from a client like a browser is waiting for a lengthy process to finish, we don't want Express to be held up and not be able to process any other incoming requests. So as a result, if the starting and the execution of a child process is asynchronous, then we are not going to sacrifice the response time for other requests when one particular request is starting a very lengthy and complicated process. The next question is whether to use a shell or not. Now, this is also a somewhat advanced operating system concept, but it is important to understand the differences between having a shell or not having a shell. A shell itself is basically a utility program that provides a rich context for any CLI to run in. So you can run a command without a shell, but not interactively. Every time you want to type in a command in order for the computer, in this case a Linux computer, to run the command, you kind of need a shell to provide an environment. So the minimum in this case for interaction is the shell would actually monitor keyboard events, and it would display outcome of running a command on the screen. So that is why having a shell is important. However, a shell also offers some other context that is important when you're executing a command. For instance, there's a path environment variable. So I'm already down here. The path environment variable is basically a list of folders where you can find commands. So typically, you don't need to know exactly where a particular command is, because a command is basically a program and it is stored as a file somewhere within the file system. So typically speaking, if the path environment variable is set up correctly, You as a user, or even as a programmer, as a developer, you don't really need to know exactly where is a particular binary executable located. That's because of the path environment variable. Now, if you opt to say, I don't need a shell, okay, then you need to know exactly where the commands or where the programs are corresponding to each command. And that becomes very tedious, really, really quick. On top of that, your code becomes a little bit more brittle because depending on the distribution, even different distributions of Linux can put some of the command files in different places. So if you build your script using no shell and you are using Debian, you may find a particular command file at a particular place, but when you switch to something that uses Red Hat, for instance, that same command can be located at a different location. So your code is now more brittle because now you have to find out what distribution you are using. Whereas if you use the shell option, then it doesn't really matter as long as where the file is located is part of the path environment variable, which is usually the case. Okay, if you're interacting with the system the way you use Red Hat Linux and Debian Linux and Ubuntu Linux, they're basically the same. Okay, and most of this stuff even transferred to Mac OS. So that is why it is important to specify that you are using the shell. I can only think of very few cases where you don't want a shell. One is you intentionally do not want to depend on the features of a shell because different shells may have different features, even though most of them are really the same. And number two is you really want to conserve memory of your computer because starting up a shell does have an overhead. It's not much, okay? It is very minimal, but it does have a minimal overhead. So if you're dealing with something like an embedded system, you're using a Raspberry Pi with very little RAM, then you might need to conserve every last byte in RAM, and in that case you might opt for no shell as an option. So section 6 gets you into the actual code, and this particular one is how a CLI command runs in a shelled environment from a NodeJS script. So in this particular case, the execution of a program would basically start from line 1, use strict, which is telling the interpreter to be a little bit more naggy. Okay, so when it spots something that might be a problem, it would just kind of give you an error or warning. And then it skips to this line, which is requiring the child process, and then put it into the constant of child process here so that we can access the methods of that particular module. And then we have a function definition. The function definition doesn't do a single thing. It is simply a definition. Until the function is called, the code that is inside the function does not execute on its own. And then we have this particular statement here, which is using the child process module, and we're using the method called exec, which stands for execute. And in this case, the first parameter that we give it is called du, which is the name of the command. Du as a command is it can recursively traverse a folder and find out how much storage is consumed by that folder and all of its subfolders. And then we have an option that is basically an empty object to specify, we don't need anything special in this case. Exec can take on a lot of different options, but we are not interested in the options in this case, so we just say, okay, we are not asking for anything special as an option, and that's why we're giving it an empty object. And then the last one is kind of important. This is the callback. So what exec is going to do is it will start the execution of the command right away, but it will also return right away. So that means console.log right after async exec is going to be printed before du is done. And that's why we have a callback. The callback itself is not called directly from your code. Instead, it is called by Node. So Node is sitting in the background and it keeps track of all the things that it needs to do when certain things are done. So in this case, when the certain thing is done, that certain thing is when the command du is done, when this child process is finished. So in that case, Node, which is which is out of your, you cannot actually see the background, the loop, event loop of Node running, but it is nonetheless there. So when Node detects that du as a command is done, then it will call whatever callback function you specify here. Now you can also see that when you specify a callback function, you don't put in the open and close parentheses, because when you put in the open and close parentheses, you're calling the function right there. It is your code calling the function, which is not the intention here. The intention here is to specify when du is done, I want this function to be called. So that's why you're not specifying open and close parentheses here, because all you want to specify is a function to call when du is done. So exec handler has three parameters. It has error, which is an error message from this would report an error from trying to run the command itself. So if the command is not found, there's not enough memory to run the command, that is what this error is going to reflect. STDOUT is actually the abbreviation of standard output, and STDER is standard error. So these are the two default, I would say, output of any program in Unix or Linux. One is a normal output. Okay, so when your program is supposed to list the entries of a particular folder, that is where you can find it. On the other hand, standard error or standard error is the output that would report erroneous stuff. And all programs have basically every single command line program has three outputs. We are only listing two here. There's one also called standard aux, the auxiliary output from the standard, but that one is really seldomly used, so we are not putting it here. So the only thing we do when the execution of the program is done is a bunch of exec, the console.logs. So the first one is to say, exec is done with an error of something, and it's typically null. You would hope that it's null, N-U-L-L, which basically means nope, there are no errors, trying to run the program. When the program is done, this particular output is going to reflect what is the actual output of the program. So this is what it would normally display on your screen when you run the program interactively using a shell. And then this will also display the error messages, which is also what you will see on the screen when you are to run the program interactively through the shell. So when all this is done, then the program concludes. So that means, right after console.log, the program is not done yet, because the event loop that is behind your code in Node is saying, hey, we still got something, I'm still waiting for something here. What is it waiting for? It's waiting for du to complete. It is only when du is done, the callback function is called, and the callback function is completely done, then your script exits. Okay, so let's go ahead and give it a try. Okay, and you can download the script. I made everything so that it's easy to download. So I'm gonna click on this, and it will just give you the text here, which you can copy and paste if you want to. On the other hand, you can also just right click on it and then select a save link as from your browser. You can see it. Let me see if I can scroll this up a little bit so you can see what I was trying to talk about. Right there, so you can say save link as. This is Firefox. I believe Chrome and Safari may have different terms for that, but doing about the same thing. So let's go ahead and try this one out. Okay, so I'm gonna download it. Okay, save link as, and I'll put it into my temp folder. Let's see, yep, we're in the temp folder, and then we click save, and then we can switch to a command line interface so that we can test run it. Okay, so here's the code. I'm going to change it a little bit because du is not long enough. It doesn't take long enough to execute. So I'm going to switch this to sleep, and let's make it sleep 5 seconds. So sleep is a command that you can run in just about any Linux console, and I believe it is the same with Mac OS. And by itself, all it does is to introduce a 5-second delay, and then everything comes back. So we can try that by hand first, right? So we can say sleep 1, and you can see it takes about 1 second for the command line to come back. Sleep 2, on the other hand, takes about 2 seconds for the command line to come back, and obviously sleep 5 is going to be annoyingly long because it's going to take 5 seconds before the prompt comes back. So that's what sleep does by itself. So now what we want to do is to say, node du callback, and you can see how it returns right away from the call to exec, and then it will do, and then when sleep 5 is actually done, that is when it would actually come back and say, oh, now we are done. In this case, sleep does not have any particular output, and that's why standard error is nothing because it's empty, and then standard out is nothing, standard error is also nothing, and there's no problem executing the command. So when we are testing programs like this, it's not enough just to run the code as it is, because we want to make it crash, right? We want to do something that will basically say, oh, this is not going to work because I intentionally misspelled sleep. Okay, let's see what's going to happen here, because we want to be able to test the program under controlled conditions, so this way we know exactly what mistake we have injected into a otherwise running program, and then we can focus on, okay, what is it going to do? How is it going to report this error? So this way, when something unexpected happens, we can now look at the unexpected behavior and see if we can match it to something that we have already explicitly tested and understand, oh, okay, when we see something like this, it's because of those particular reasons. So let's go ahead and test this one, and we know it's not going to work, but we want to know what it's going to report. So right now it says, exec is done with an error of, everything within the double quote is coming back from the shell itself. So this entire message here, error colon command failed sleep 5, and bash slash bin slash sh, which is the shell. Sh stands for shell. It says sleep not found. So it gives us an idea of what is going on, why is the command not working, right? So now let's try to see what sleep is going to do when we specify a switch that is just gibberish, okay, that it doesn't understand. It complains, right? But this is not going to report it the same way as the first problem, because the command actually ran in this case. It is the command itself, not the shell, that complains about invalid option, blah 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 blah, and then try sleep -- help for more information. So now we change the program again so that sleep itself is spelled correctly, but we are specifying some gibberish options here that sleep does not understand, just like what we did earlier. And then we try to run the program again just to find out what is going to happen in this case. So in this case, error itself actually does copy what the standard error is reporting. So now we understand that oh, so the error string, the error parameter includes everything in standard error, and this is the actual standard error, which is what is displayed on the screen when we try to run it interactively. So this is really, I think this is really helpful, just to kind of try to make the program not work intentionally, just so that we can see what it's going to report back. Now, for those of you who say, but I want to see something that has a standard out, okay, something that would actually output and something that's obvious, okay. Well, that's not too hard. We can do an ls. Okay, ls is one of those commands that has plenty of output, or at least they're predictable. So now we change the command here to ls-l, which is long, and then h, which is human readable format. So this way it will display the size of a file in kilobytes, megabytes, and so on, instead of giving you just a really long number to interpret. Okay, so that's all we need, and then we say node, and here this is the output. So we want to scroll back. We can see that error this time is null, which means there's no error in the execution. And then standard out is all the way from here, starting with the word total, and then it goes all the way down to right here, including this new line character. And then standard error is nothing because when we ran the ls command, there's no problem. Okay, so we don't have any issue with this. All right, so so this is just me illustrating to you guys given a particular sample program, there are things you can do to it. There are very few things you can do that will actually cause harm. Running RM is one of those, because RM is how we delete files, and if you do rm-r, uppercase R, it can delete files recursively, which means if you start it in a folder, not only are the files in the folder gone, but all the subfolders will be gone as well. So there are few commands where you don't want to experiment with, but most of the other commands, especially the ones that only report some kind of a status, is actually pretty good. I mean, you can use those and just test things out. All right, so that pretty much concludes this particular sample program. But you can see this sample program here is using the callback, okay? Because if you were to write a program like this, you have to specify the callback, and it becomes very difficult to sequence operations, because if you want to say, okay, when whatever command I run here, okay, it can be du, can be ls, can be sleep, whatever, right? So if you say I want to do something when it is done, the only place for you to specify the continued operation is within exec handler here, right after the last console.log, or you can replace the console.log with something else. But you will be basically dealing with a whole bunch of callbacks, and they are linked by calls like this, where with every single one you have to specify, oh, this is the callback to that one, and by the way, when that is called, I want to start a new operation where that other callback is how we respond to when that operation is done. So your code is going to be difficult to read, and that's why we are going to move on to the concept of promises. Now, promises doesn't really get rid of the problem that we have at hand, but it does give us a way to modularize our code. So basically what is changed here is I can execute a function, and the function can have an argument of what command we are trying to run, and this makes it kind of more modular, because now we are not stuck with just running du itself. We can run any command. And the way this is structured is shelled command, which is new compared to the previous program, is just a regular function, but it has the other function, which is exec handler, as having it defined within one function. And this is one of those things where you can easily do within Node. You can define a function within a function. So within this exec handler, it actually has access to everything of the parent function, the function that's including it, including all of its parameters. So the parameter command, which is passed to shelled command, is also accessible inside exec handler, which is a you can call that a sub-function or nested function that is defined within shelled command. The way exec handler is done is about the same, except we are parameterizing what command is being done, because now we can actually know which command is being done. This time we are using oh, this is just parameterized. Sorry, I take it back. This is not using promises yet. This is parameterized, which is because we need this to be parameterized in order to use promise. So this one is functionally about the same as this one here, except it is parameterized so that we can run any command, and we are not hard coding what command to use when we get to exec, because exec itself is within a particular function that takes the command. So it's one level of encapsulation that will allow us to basically specify, use the same function, but use different commands if we want to. So you can have one shelled command instance to use du, another one to use ls, another one to use sleep, and so on. So this script is just a minor improvement of the first one. And then the next one, listing 3, does use a promise, and it does make the code a little bit longer. And the reason why it makes the code a little bit longer is when you use a promise, you also need to specify what you want to do when the promise is resolved. So there are a few steps when you're using a promise, and let me illustrate it in the code here. And if we follow the execution of the program, the first thing it does is to call shelled command with du in it. Okay, so we get to shelled command, which is right here, and then du is the command. Now remember, any function definition by itself doesn't execute by itself. So all this stuff here is basically ignored, and Node would go straight to this particular statement here. This statement takes up 3 lines because I want to emphasize that promise, when you create a new promise, it will basically need a callback function. The callback function, which is one of the required parameter or argument to make a new promise, is basically to say, okay, this is the operation that we want to start. So return new promise with a callback function will kind of, right away, you'll start up this operation, whatever this function is trying to do. And what this function is trying to do is defined here. This is what to do. And when you specify a callback when you create a new promise, it has 2 built-in, or it will be passed along 2 specific arguments. One argument seen as is resolve, and the other one is reject. These 2 are callback functions, but they are not callback functions that you specify. These are callback functions that Node specifies when what to do is called, when Node gets around to call it. So resolve is a function that you call when you say, yeah, what I want to do is actually done now. That is when you call resolve. Reject, on the other hand, is when something bad happens and you say, oh, what I promised to do, I actually could not do it. Okay, and that's what reject is for. So we're gonna ignore reject for the time being. We're gonna use resolve only. So when what to do is called, all it does is to call process.exec. Whatever command is here is going to be visible here, and then it also specifies exec handler, which is this one here. But you can see how this time exec handler is not just doing a bunch of console.log. Instead, it is taking error, standard out, and standard error, and also the command itself, which is also visible when exec handler is called, and it's taking all of that stuff in order to create an object. So the object being created is specified here, and what resolve is going to do is to say, okay, let me create this object here and use it as the resolution value. So when resolve is called, which is when the command itself is finally done, it's going to call resolve to basically indicate and say that this promise is done. Okay, I have fulfilled my promise. Okay, so resolve is kind of the same thing as fulfilled in the context of a promise, and in that sense, reject is kind of like broken a promise. Okay, so if you really want the name of these parameters to reflect what we understand promises in a colloquial sense, you might want to change this one to keeping a promise or fulfilling a promise, and this one is breaking a promise. So that's basically what it is. But exec handler is not going to be called by you or your code either. It's going to be called by Node when the command is done. Okay, so that aspect, is the same as what we have already discussed in the previous sample program. Okay, so what about when this is all done? So basically, when shelled command is done, all it's going to do from the perspective of your code is you're going to get a promise object. In other words, when you look at just this portion of the expression, it returns a promise object. And the question is, so now I have a promise in my hand. What good is it going to do? The answer is not much. I mean, that's just a promise. That's basically a promise that was created by calling shelled command, and the system is the one that is trying to fulfill the promise. And then the next question is, when is it going to be fulfilled? We have no idea, because we have no idea how long this particular command is going to take. But the promise is returned right away. Okay, in other words, as right after your script calls shelled command, it's going to return the promise object, and that means this .then executes right away. It doesn't wait until the command, the CLI command is run. This is done right away. So what then as a method is going to do, then is a method of a promise. Okay, so every promise, has a method called then. In order to specify, what happens when the promise is fulfilled? Tell me what we are supposed to do when the promise is fulfilled. In the form of a, guess what, callback function. So this callback function called after shelled command is specifying, when the promise that is created from this function call is fulfilled or resolved, we are going to do this, whatever code is specified in this callback function. So that callback function is specified here, and value is not the only argument, it's not the only parameter, but in this case, we only care about the value. So the value is actually whatever resolve is the argument of resolve. In other words, whatever we specify here as the resolution value is going to be passed on to the value of the callback of whatever you specify as the quote-unquote then operation. Yeah, I know this sounds really, really convoluted, right? So in this case, line 35 executes just like that in an instance, and then we get to console.log right after shelled command. In other words, when we get to right after shell command, the command that we are actually trying to execute is still in execution. More likely than not, that's going to take a long time to execute, and we're going to see the message right after shelled command long before the command is actually done. Now, when the command is done, okay, let's say we're doing a sleep 5, okay, when the command is done, the first thing it does is to do the exec handler, and the exec handler is going to do whatever it's supposed to do, capturing the error, the standard error, and the standard out and the standard error, and also the command, and combine all of those into a particular object. This object in return is being used to call resolve. So resolve is what is linked to the promise. So resolve is telling the promise object, go like, hey, we're done. And then the promise object, which is very integral to the node environment, will then go to the node event loop and say, hey, here's one thing that you have been waiting for. It's done now. At that time, it's going to use whatever you specified earlier as the action to perform when the promise is fulfilled, which is after shelled command. And only at that time, after shell command is actually going to be called, once again, not by your script, but by the node event loop. So this is something that is hidden from you that you cannot see. But what value is going to be in that case is the resolution value, which is what was created earlier when exec handler has created. So that is why by that time you will be able to access command as a member of the value, because value is actually an object in this case. It also has an error because that's how we constructed this particular object here. It has command, error, standard out, and standard error as its members, and we're accessing every single one of those members in 3 different console.log statements. So the effect of the program is the same, but this time we are using promises. So what is good about promises? Well, what is good about promises is it separates what you want to do after the promise is fulfilled into a place where you can easily specify something else. So if you want to just have a delay, and then you can specify what you want to do after the delay. If you are specifying a DU here, you can specify something that can parse the output of DU to figure out how much storage is being used in the folder that you are by default is the working directory, but you can basically say, okay, I can see that this folder is using this much space. Okay, so whatever you want to do after the command is done is easy to change and easy to be modularized in this case, and that's the benefit that promises are giving us. But you can see the code is still complicated. Okay, you as the developer still has to fully understand what is going on, what happens first, what happens next, what is being handled by the event loop of node, and when something is done, the event loop is going to say, hey, this is done, I'm going to call this callback. That callback in return specifies a resolution value, which in return triggers another callback to execute. That is complicated. Okay, I'm not pretending that this is easy to understand. This is complicated. But that is why this module is not done. This is counterintuitive, right? Yeah, we are getting into something that's complicated and it's not done. Are we going to get to something that's even more complicated? Well, the answer is no. We are actually not going to make this program any more complicated. Now, with every single complication, okay, you're starting from listing 1, which is the shortest program, but it's also the most brittle program, which means it's really hard to use this code and extend it to do something different compared to DU and do some processing other than just doing a console log. It takes a lot of copy, paste, and modify to get that done. And every time you do any type of copy, paste, and modify, you are making your code very, very brittle. Okay. For one thing, if what you're copying from has a mistake, now you have multiple copies of that mistake to fix. That is not a very good idea. The second program is a little bit better because we are separating what we want to run into a parameter, and then we can just call a particular function, but we can't really quite specify what to do after the command is done because it is still hard-coded within your shell command itself. With promises, we are now separating that. Okay, with promises, we are now saying, hey, when the command is done, all we're going to do is to capture the result of the command itself, and then we are going to use it as a resolution value. Whatever you use as the then method, okay, which in this case is after shelled command, is up to you. So that means we are now giving the program a lot more flexibility to reuse code. But it does make the code complicated to read and complicated to understand. So what we're going to do next, okay, is this is actually a list of the every single event or operation that happens as we run this program with promises. Okay, and you can read through this. Basically, it's just a written version of what I said earlier. That is not good, okay? It's not suitable for a class like this, where people may not have any programming experience before. And I can tell you this right away, okay? Not gonna lie about this. Even people who have taken 2 or 3 classes in CISP, in the CISP discipline, the programming discipline, like CISP 300, 360, and 400, even many of those people are gonna have problem understanding promises. So what we're going to do is we are going to keep some aspects of the program. So shelled command is going to be exactly the same, but this time I'm going to ask you to ignore what shelled command is going to do. Okay, just when you think of shell command, just think of it from this part here and not to care about how it is defined. Okay, all you have to remember is I'm going to pass a command like ls, like du, like sleep, or whatever, for shelled command to run, and it's going to do it. Okay, but what about all those concepts about promises and callbacks and whatnot? Don't worry about it. Okay, why not? Because we're going to use async and await. So when you use async and await, async applies to a function, where within the function you can use await. That's what async is. So when you want to use await, you cannot use await, out here. Okay, you have to use it inside a particular function definition. You cannot use it outside of a function definition. So the first thing we do is to say, okay, fine, that's easy, because all we're going to do is to say, I'm going to define the main function, and the only line of code outside of the entire program is to call main. Okay, that's pretty easy to arrange. But now I can make main async, which means it within the main function, within the body of main, which is this portion of the code, I can use the word await. So last time when we specified shell command, this time this definition of shell command has not changed. We have to use .then, and then we specify callback for the then in order to specify what to do after the promise is fulfilled. This time we don't have to do a single thing. This time we just say, hey, let's await this, whatever promise is coming back from this call to shelled command. And this await here is basically, that's the magic word to basically say, let's not continue further execution until the promise is fulfilled. When the promise is fulfilled, by the way, don't give me the promise, give me the resolution value. So this entire thing, okay, so let me highlight what I'm talking about here. So this entire thing is basically saying, I'm going to call someone that can return a promise, which represents some operation that will be done sometime in the future, and it's going to have a resolution value. But you don't have to worry about a single thing, because I'm going to pause execution until that promise has resolved, and I'm going to give you the resolution value itself. So you, as the person who's utilizing this function within an async function, you don't even have to worry about anything about the promise, about callback functions, none of that, okay? All you're going to have to say is to say, I want to get this done and give me the result when it's all done. So when result is getting a value, because this particular expression is done, is getting the object. It's getting the object that has the command, error, standard out, and standard error as its members. So result is basically, it has its command, it has its error, it has standard out, it has standard error. So now whatever you want to do with the resolution value of the promise, you just stash it here. You don't need to define a callback function to contain all this code and then use the .then in order to specify what to do. You just say, hey, when this is done, continue with this, because the await keyword is making Node to basically pause execution until the promise is fulfilled. So this here, okay, so now your focus doesn't, you don't have to focus on how shelled command is done anymore. Your focus is really just, how do I use shelled command in conjunction with await inside a function that is declared async. And that's what we're going to do, in our Express script, because we have already talked about how to enable async, as a for the handler of an endpoint. So this is why we are talking about this, is so that we can use await when we are shelling out to get something done. So that's basically the idea of this particular module. There's no specific lab to do, for this particular module, but as I said, you probably want to try out all of these things. Okay, so just download the script. Okay, so right click on Save Link As, get it downloaded, and of course in your case, unless you're running Linux or Mac OS, you probably need to upload it to the Power Server in order to experiment with it. So once you have the code on the Power Server, let's just pretend this is the Power Server. It's not, but it's close, right? So now we can go to async.js, and as I said, just ignore how the definition of shelled command. So ignore all of this and just go straight to the main function here. And if you want to change this, you can just change du to sleep 5, so it will sleep 5 seconds. And if you also want to, you can make another await down here, and this time you don't even care about the output, so you can say await shelled command, okay, sleep another 5 seconds. And also, instead of using console.out, let's do the very roundabout way of outputting something, okay, because there is a command called echo as a shell command, and you can now say echo. Now, since we are using double quotes, to quote the string from the perspective of JavaScript, so when you try to quote the string to echo, you cannot use double quotes anymore. Single quotes will work in this case. So you can say, this is from echo. Okay, there we go. Double quote to end the string, and then to close this. So now we are going to, okay, let's do one more step here. So this time we are basically specifying a bunch of operations, for shelling out. Now, to do something like this using promises or callbacks, this program is going to be a big mess, okay? But since we can use await and inside the async function, this is now a whole lot easier to read. So let's go ahead and give it a try. And the program would wait 5 seconds first. And it's going to say right after the shell command. And oh, right, because the output of echo is in the standard output, and that's why it's not showing on the screen. So I have to change the program a little bit. What I'm saying is the shout command here, it's echo normally would put something on the screen, but since your shout command is capturing the output into the standard output member of the resolve value, so I'm going to show you something that's kind of cool here, because we know await blah blah blah, this entire thing is returning just the resolution value, which is an object. We can access it right away, so we can just say, let's output standard out from here, and then we enclose this entire thing with a console.log. Alright, so we can do it like this. Sleep 5 has no particular output that we're interested in, so we can just leave it alone. And then this one we'll use the same approach, which is using console.log to enclose, just printing std out from the object, the resolution object that is the result of running a shelled command. Alright, so this time we should have some output that is what I was originally intending. Let's give it a try. So another sleep 5 echo, and this is from echo. Okay, so the program does work the way it's supposed to. So I encourage all of you to kind of just play with this. Okay, find some command that you want to do in Linux, stash it in here. And if you want to process the string, or if you want to process the actual output of running a command, you can do so too, except we haven't really talked about a whole lot of string processing ability inside with JavaScript, so there's not much you can do with processing a string at this point. So just printing it out on the screen is going to be enough. But before I stop, okay, there are a few commands that you might want to try out. The first one is time. Okay, so time is really just timing how long a particular command takes. So if you're running a command that takes a long time, like sleep 5, it will tell you how much real time it takes, how much user time, which is the processor spending on your process, and how much time system, which is the processor spending on system code, and you will find it quite interesting. Okay, so let's give it a try here. So it tells you that in real time it takes 5.003 seconds, but in terms of actual time used by the processor, it spent 1 millisecond, which is 1,000th of a second, on resources that belong to the user, and it spent about 3 milliseconds on resources that belong to the system. So most of the time is actually not doing anything, because as you can probably imagine, sleep is just a delay function. The other one that is also interesting is date. Okay, date actually just returns the current time and date, and you can see how this might be helpful if you want your Express script to know what time it is at this point. Another one that's also useful is uptime. Okay, you can run all of these commands inside Linux, by the way, using your accounts on the power server. So uptime tells you how long the computer has been up, how many users are in the system, and what is the load average of the system. This is actually rather high, and partially because I'm recording right now, and so it has to do a lot of things, but it's not really that bad. I mean, the system load is actually within reason at this point. So there are all kinds of little commands that you can run, and because you can do it inside your Express script now, it expands the capability of your Express script by a lot, because now you can say, hey, I know how to do this by hand interactively. Anything you can do by hand, you can now do it inside your Express script, and that is one big huge step compared to PHP, because PHP is very, very protective of what it can do, what kind of command it can run from inside the script, and also when you run the script from inside the PHP script, it is not being run as quote-unquote it is being run as Apache 2, which further puts complications and limitations to this entire process. Express, on the other hand, the way we're going to use it is going to run the command just as you are running the command. So that gives you a lot of flexibility as to what you can do with your Express scripts. So I'm going to stop here. Okay, this is enough material for you guys to absorb for a while, and then I'm going to make another one on an even more complicated concept, and that has to do with gosh, I'm drawing a blank here because I just wrote the module the other day and then I forget about what I was writing about. Let me think. I think the music is gonna help. Right, sessions. So that is going to be a longer discussion because there are a few concepts, and then the sample program that makes use of session is by itself a little bit interesting, but it's also a little bit complicated to explain. So I'll make another recording for sessions in Express.